So we're going to start a discussion on rocks, and rocks are it's a fairly big topic, and I'm probably going to try to break it up into a couple of different videos. But if you're following along, just to let you know, the guided notes look like this. These guided notes are found in the packet that you have, but if you would prefer to have a larger print version of these guided notes, those Word files are available on my Canvas website under Unit 3. Right? So first of all, what is a rock? Okay, a rock, rocks are any solid mass of mineral or mineral-like matter occurring naturally as part of the planet. All right, if you watched the previous video, we went over the difference between rocks and minerals. Keep in mind, rocks are made up generally of several different types of minerals. A mineral itself is one pure substance. So there's three major types of rocks, and the thing that makes these different types of rocks different is how they're made. All right. So the first of these types of rocks is what's called igneous rock. All right. And igneous rock is a rock that is formed by the crystallization of molten magma. Okay. You might not have heard of the term magma before, but most people have heard of lava. All right. If you've ever seen a volcano erupting, you know that it generates this liquid, essentially melted rock material. All right, magma is just lava that is beneath the Earth's surface. Okay, so when it's beneath the Earth's surface, we call it magma. When it comes to the surface and it flows out, we call it lava. But it's essentially the same thing. The next major type of rock is a sedimentary rock. All right, a sedimentary rock is a rock that is formed from the weathered products of pre-existing rocks that have been eroded, deposited, compacted, and cemented. Okay. The last major type of rock is a metamorphic rock, and that's one that is formed by the alteration of pre-existing rock deep within the earth, but still in its solid state. And this happens by application of heat and pressure, and possibly some other chemical agents. So the thing about these rocks is that they don't always have to stay that type of rock. All right, any of these types of rocks can be turned into the other types of rocks through natural processes. We describe the way that these rocks can be turned into the other types of rocks with what's called the rock cycle. Right? For example, igneous rock, which is the type of rock that we said came from cooled magma, can be broken down into smaller bits of rocks called sediments. All right, and these sediments can get turned into what's called sedimentary rock. All right, we're going to talk a little bit more about these rocks later. Right now, I just want to focus on the fact that these things can be turned from one type into the other. All right, every arrow that you see here is a way that, for example, metamorphic rock could get turned into sediments. All right, through this process right here, and those sediments could then get turned into sedimentary rock. All right. Alternatively, metamorphic rock, if you get it hot enough, can melt and make magma, and then that magma could cool down and make igneous rock. All right. Igneous rock, if you put it under enough heat or pressure, can get turned into metamorphic rock. All right. So all of these types of rocks are totally interrelated, and we'll go a little bit more into that later. So, as we were saying, the rock cycle, it shows the interrelationships, all right, the way all these different types of rocks are interrelated among the three rock types, which are igneous, sedimentary, and metamorphic, all right. So, some key vocabulary that we need to know, all right, magma is molten material, all right, that's molten means melted, that forms deep beneath the Earth's surface, all right. Magma is essentially the same thing as lava, except for lava is what you call it once it reaches the Earth's surface. All right. So if you can see it on the surface of the Earth, it would be lava. It would not be magma. Okay. When we talk about sedimentary rocks, we're going to talk a lot about weathering. All right. And weathering is a process in which rocks are broken down by water, air, and living things. All right. One way that you can think about weathering is like what you would be doing to a rock if you just took a rock and took a hammer to it and you just broke it up into smaller pieces. All right, you would take one big thing and turn it into a bunch of smaller things. All right, in nature we don't really have hammers that do this. We have other things that do it. Water is the number one thing that does this. All right, another thing that can do it is just air and living things. For example, when a tree grows, it sends its roots down into the ground, and as those roots grow, they can get in between rocks and break them apart. All right, so weathering is just the process of the rocks getting broken apart. Once rocks are weathered, it generates what's called sediment. All right, sediment is the weathered pieces of the Earth's crust. All right, it's the weathered pieces of all those rocks. So the conversion of all these types of rocks into the other types of rocks that we describe in the rock cycle, it all takes energy. All right, so where does that energy come from? All right, so sometimes the energy comes from within the Earth, and sometimes the energy comes from sources outside of the Earth, primarily the sun. All right, so for igneous and metamorphic rocks, the place that the energy comes from is from the Earth's interior. All right, although it might not feel like it when you're on the surface of the Earth, the inside of the Earth is actually very hot. All right, and a lot of these rocks are formed, deep below the surface that we live on. All right, so that's where the energy comes from for those types of rocks. All right, in contrast, for sedimentary rocks, we need weathering, and weathering is the breaking down of rocks, and the energy source for all those processes are provided primarily by the sun. So essentially, external processes produce sedimentary rocks, whereas the energy required for the igneous and metamorphic rocks come from interior sources, right? Heat sources that are generated from within the Earth.